Quantitative aspects of electrolysis. When we are passing current through the electrode into the electrolyte, then chemical change takes place, that is oxidation and reduction reaction at respective electrode. Then whatever the deposited or liberated gas at their respective electrode, how much it is deposited or liberated, that is explained by using some laws, that is called Faraday's first law and Faraday's second law. So now I am discussing about the Faraday's first law. Faraday's first law: the amount of chemical reaction which occur at any electrode during electrolysis is proportional to the quantity of current passing through the electrolyte, that is solution or melt. That is called Faraday's first law. This can be we can understand by using one example, that is called, for example, aluminium. Aluminium plus 3 electron. This will be convert into aluminium. Now this is 3 moles of electron, deposit 1 mole of aluminium. Now 3 moles of electron is called 3 Faraday. So 1 Faraday is equal to 96,487 coulombs per mole. Now, how we can get this 1 Faraday? 1 Faraday is equal to, what is that? 1 mole of electron charge. 1 mole of electron charge. Now 1 mole meaning what is that? 1 mole is equal to 6.022 into 10 power 23 electrons. So this is 6.022 into 10 power 23 into 1 electron charge is 1.602 into 10 power minus 19. So after multiplying this one, we will get, this is 96,488 or 87. It depends upon the which value we are using here, 6.022 or 23 or 2, depends, small change. So therefore 96,487, this is coulombs, because here this is electron coulomb for 1 mole of electron, therefore coulomb per mole. This is called 1 Faraday, and this is round of value is 96,500 coulomb per mole. Now we have here 3 into Faraday is equal to 96,487 according to textbook, coulombs per mole, and this will be deposit here 27 gram per mole of aluminium. Now this can be, once again I am writing here, Al plus 3 electron convert into Al. Then this is called 3 into 96,487 coulomb per mole, and this one is 27 gram per mole. Now something here deposit, how much mass will be deposit? Mass is equal to how much deposit. If they ask, then here what is required? Charge. This is nothing but what is that? Q. Then here for this charge, this much deposit. For this charge, Q is equal to what is that? I into T. For this one, how much deposit? So this can be given as Now we are going to calculate which one? Mass. So mass is otherwise here I will write. So mass is equal to, what is that? Crisscross method. These I into T or Q first, right? Q. This is a Q. And multiply with which one? This is a molar mass. Therefore, I will write here a molar mass. 1 mole mass, that is called capital M or MW, right? Molar mass or molecular weight. Divided by which one? This one. So now 3 and into Faraday, that is round of value, we can write here 96,500 coulombs. Now we can create one formula. This 3 is which one? N factor of valency. Therefore, M is equal to molar mass into Q by this 3 is which one? Valency for the metal, number of electron transfer this is, and into 96,500. Now little extra, mean already we know Q is equal to I into T. Substitute in this formula. M is equal to M into I into T divided by this valency V and 96,500. So this is generally formula for Faraday first law. This actually derived from these two lines, this one and this one. So you can remember this or you can derive from these two lines. And now this formula can be represented as equivalent weight is equal to, what is that? Molar mass by its N factor is called here valency. Therefore, formula can be changed as mass deposited or liberated is equal to equivalent weight into I into T and divided by 96,500, because this one is now written as a equivalent weight. So therefore this is a formula. Next, we know that Q is equal to 100% charge, that is 3 into 96,487 coulomb. Then how much deposited? This is 27 gram. In case some percentage, because here Q is equal to, what is this is? Q is equal to Q is equal to I into T. This I is 100%. In case now this Q is equal to I into T, if it is any percentage X percentage, then how much deposit? Then formula will be, this is nothing but mass. So mass of the substance deposited or liberated, that equal to, what is it? This is I, now cross multiply, I into T into which one? Molar mass. This is molar mass divided by this one, and this is called valency 3 and 96,500. This is valency, this is 96,500, round of value I am writing here. Now this is 100%, that's why here multiplied with the 1. Now this is, or this is I. How much percentage? We don't know. They will give in the question, that is a X percentage. That is in the fraction we have to put. Therefore, formula will be X percentage into I into T into molar mass divided by its valency. Now I am writing below this M and 96,500 coulomb. So X percentage means, for example, 50 percentage, meaning you can write 50 by 100, that equal to zero point 0.5. Like this we can write and substitute in the formula. Okay, this is one formula. This is about the Faraday's first law. Now, sometime in electrolysis process, what will happen? This is a one electrode, that is a cathode. On this, what will happen? This some substance is like this coated or deposited. That is called, this much thickness will be deposited. So this can be given as like this. So we know that density is equal to mass by volume. Then mass is equal to density into volume. Now this is a density. Volume is equal to area into thickness. This is. So now in this formula we can substitute here. Then this is a mass. Mass place we can place this one is equal to, now percentage of X I am removing and just writing here, equivalent weight into I into T divided by 96,500 coulomb. So when density given mean, immediately in your mind should be come this formula, density into volume. So volume place, what is that? Volume is, we know that V is equal to area into height. Here height place, that is we are calling as a thickness, because that much a thin layer deposit on the electrode. Therefore, now the formula once again I am writing, mass place what I am writing, the density into area into thickness is equal to equivalent into I, current into time. Time always in second, don't forget, 96,500. So we know that time should be taken in second, and I, current units is a ampere. So 1 hour is equal to, what is it, 60 minutes. 1 minute equal to 60 seconds. Therefore 3600 seconds. Keep in mind, because sometimes they may given hours also, minutes also, second also. Always we have to put in this formula seconds. Now we are going to calculate one problem here. Now one question. A solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 ampere. What is the mass of copper deposited at cathode? Now we will write equation. Copper sulfate, meaning this is CuSO4. CuSO4 ionized into Cu plus 2 SO4 minus 2, which will be deposited at cathode after undergoing reduction. So Cu plus 2 ion undergo reduction, SO4 minus 2 ion undergo oxidation. Therefore Cu plus 2 plus 2 electron convert into Cu. Now its 2 mole react with the copper plus 2 deposit 1 mole. Then this is called 2 Faraday. 2 Faraday deposit 63.5 nearly gram per mole. Then how much here? This is 2 into 96,487 coulomb. Deposit 63.5 gram. Now according to this is nothing but which one? Q only. Now given Q how much? That is current is 1.5 ampere. Ampere meaning what is that? Current is equal to Q by T, that is coulomb per second. Therefore ampere place we can write here coulomb per second, and here 10 minutes given, 10 minute, 1 minute equal to 60 second, therefore 60 second, second cancel, and this much charge, this is deposited this much, this will deposit how much? Therefore now mass of copper deposited is equal to, what will get formula here? 63.5 multiplied with the 1.5, that is coulomb, into 10 into 60 divided by 2 into 96,487 coulomb. So this is general in gram. Now what happened after all these cancellation? You will get the answer. Roughly I am writing here 0.3 grams. So you can do like this. Otherwise you can use this formula. Mass deposited is equal to equivalent into I into T by 96,500. Otherwise E mean what is it? Molar mass by valency, I into T by 96,500. Direct this formula, because in this one mass is this one and this is called valency, this is called I, this is both is time, and this is round of value 96,500. Like this we can calculate. Now the question is, if a current of 0.5 ampere flow through the metallic wire for 2 hours, then how many electron would flow through the wire? Now this can be calculated as 1 Faraday is equal to 96,500, otherwise exact value 96487 coulomb. This is for 1 mole electron, that is nothing but 6.022 into 10 power 23 electron. So now we have charge, that is I into T is equal to, that is I is given 0.5 and time is given 2 into 3600 in seconds. Then this ampere means coulomb per second, this second cancel, coulomb only. Then this will have how many electrons? Therefore we have to multiply now. What is that? 0.5 into 2 into 3600 into 6.022 into 10 power 23 electron divided by 96487. This is coulomb cancel. So now this is 0.5 into 2, that is 1. Now if you multiply that, these all multiply and divide, you will get here 0.2246 into 10 power 23 electron after multiplying divide. Therefore point shifted to right side means 2.246 into 10 power 22 electron. These many electrons are present. Now question, consider the reaction Cr2O7 2 minus plus 4H plus 6 electron convert into 2Cr plus 3 plus 7H2. What is the quantity of electricity in coulomb needed to reduce 1 mole of Cr2O7 2 minus? Now, this can be written as according to this equation. Answer is Cr2O7 minus 2 plus 14H plus 6 electron gives rise to Cr plus 3 plus 7H2O. Now, what is the quantity of electricity needed? What is the quantity of electricity needed in coulombs? It means here 6 Faraday required to reduce 1 mole of Cr2O7 2 minus. Then answer is, anyway this is a 1 mole only is there, nothing is there here, meaning what is that? 1 mole. Therefore, this 6, why I wrote here, so 1 Faraday, 6 Faraday, because 6 electron is there, so 6 Faraday. So answer is in 6 Faraday, but in coulomb that is required. Therefore, 6 into 96,500 in coulombs. So, for this 1 mole of Cr2O7 to reduce into Cr plus 3, for this, after multiplying this value, you will get 579,000 in coulombs.